All right, we are back again, part 2 of making a compiler and our own programming language called Hydrogen. So we left off last time with just compiling this simple program of just returning 2 as the exit code. And so if I go ahead and run that, which is in this cmake debug here, and then we run hydro actually this is the compiler. So we're compiling it here. Like that, and then we can actually go ahead and run it as ./out, and then if we look at the exit code, we get a 2. All right, so that's where we left off. One thing that I noticed right away is I'm using return here, but this is actually more like exit in C, right? Like if in C you'd have exit and then like 2 like that. So I think it would make more sense to call this exit instead of return. I'm not really sure why I called it that, but I did. So we'll change that and we'll refactor some of the things here. And maybe we'll get to parsing today. Hopefully we can do that because that's where the interesting things start to happen. Okay, so looking at our code here, we have our tokenizer here. So let's actually make the change I wanted to right away, and that's to make it exit, which is not a keyword, it shouldn't be. Okay, so let's just look for anywhere we use return, and let's make it exit, just so we can, because I think that just makes more sense. So looking for return anywhere. That looks like it did it. I have one warning. Enum constant is never used. That is interesting because I thought I did use it. I'm clearly using a C-line. You don't know what you're talking about. Okay, let's just go ahead and try this. So running this, it says I messed up. Okay, so I apparently messed up. Interesting. Because I did mess up, because I changed the syntax and didn't actually change the program. So it should be something like this now, right? So now that should compile, and then we should be able to run it let's just go into the cmake folder here, cmake build debug, and let's go ahead and run ./out. If I can spell echo 2, let's actually make sure, let's put a 20 just so we can do this. Let's just put this all in one line. You know what, that probably doesn't work because this echo checks the output of the exit code of the last command, so I don't know if I can like have both of them on the same line like that. Ooh, did I compile it? I don't think I did. There we go. Okay, so it's all working. It's all working. Cool. So the first thing I want to do is this whole manual manipulation of the index with doing this I++, I-, while like this is kind of messy. So what I want to do is I want to I want to create a class for tokenization and create a couple methods for better manipulating that's better for how we're going to process the individual characters in our source file. Right, so let's actually go ahead and create a new header file, and I think I'm just going to make everything inline for now so I don't have to create another CPP file for the implementation. There's really there's no other reason other than I don't feel like having to split things between 2 files. So let's just call this tokenization. Tokenization, that is how you spell that. Okay, and this is HPP. We will add it to Git. I don't like this. We're going to use pragma once because we are doing modern C++, even though this isn't part of the C++ standard. Who cares? Right, this is undefined behavior. Yeah, just kidding. Okay, so, and if you don't know what pragma once it just means that it's only going to include this header file once, even if we include it in multiple files. If we use it multiple times, it will only actually process it once. So let's see here. Let's create our class. So we're going to call it the tokenizer, and we're going to have a public and private stuff in here. I also did create a proper claim format file, so we will have a somewhat decent formatting. Okay, so what I want to do is in the constructor of our tokenizer, so this is going to inline, everything's going to be inline. Inside of our tokenizer, we're going to take in a string of the source code. So we'll do string of the source code. Okay, this isn't being included. I need to include it in main because it's yelling at me. Okay, so I will include it. All right, so you can stop yelling at me. C line. Why are you still yelling at me? Did I misspell something? What did I do? No header in hash include. Am I going crazy or what? Ah. There we go. Cool. That fixes it. Okay, so we have our string, and this is going to be our source. So maybe I'll call it source. Yeah, we'll call it source. And then what we will do is we will keep that as a constant string in here. And I like to prefix members with m underscore so that we know they're members. Okay, so we will actually construct this with an initializer list. So we'll do m source, and then we will put source in here, like that. Cool. We could do something like this. We could take string in here and then do a move if we want to like not have copies. I think that's a better way of doing that. Not that I really care about performance that much right now at this moment. Okay, so we're going to move our source code in here, and then we will have a method. This will be a public method of tokenize, and this will return us a vector of tokens, right? A vector of tokens, token. Just like that. This will be inline as well because I don't feel like writing stuff in separate files. And we'll take our token type and our token, and we will put it in this file over here, just like that. And then we will go ahead and I guess we'll take all this code for now, but we're going to replace all of it, okay? So we're going to throw this in here. I believe I need to include some things in here. I think I need to include string, include vector, and including something else. Okay, so what the two methods that I want to implement are peek and consume. So peek as in like peeking ahead, and then consume meaning consuming a character. And that'll take care of, instead of doing this I plus plus I minus minus, we can peek a character, see if it's even there, see if it's the end of file, and then if it's the type of character that we want it to be, we can then consume that character, which is pretty much like doing I plus plus, but we'll just have a couple methods to do that, and these will just be some private methods to do that. So first one is peek, which will return an optional character. And the reason why we're going to return an optional is because if we peek ahead, it might be the end of the file. And if it's the end of the file, then we're not going to have a next character, so it's going to return null. But in most cases, it should return a character. And this is going to be a constant, meaning that it's not going to change our source code at all. In fact, really, nothing should change the source code because we made it constant, right? The tokenizer shouldn't actually mess with the code. Okay, so we need to peek ahead. So we need to keep track of where we currently are. So let's actually have an index inside of our, I'm not sure if, do we? I'm wondering. Do we put it in here? Yeah, we'll just make it a member for now. We'll just make it an integer, m, and then we'll make it the current index, but that's kind of a big word, big couple of words. Maybe just index. That's fine. So we have peek, and we're going to return. First of all, we need to check to make sure that the the next character doesn't exceed the length of our source code. So we're going to do if m index plus 1, if it's greater than or equal to the source's length, then we will go ahead and return nothing, return a null. Else, we will go ahead and return mSource at the index. So one of the things someone mentioned to me is, why am I using .at when I could just use this? What is this called? This is the index. I can't even remember the name of this. But I don't like using that because with .at you get bounds checking, and I'd much rather get bounds checking, especially when I'm prototyping and stuff, because I don't want to, because I'm just prototyping and I don't want to run into undefined behavior. And bounds checking I mean, computers are fast enough. We don't need to get into these kinds of optimizations yet. So we will go ahead and return that, and that should be it. And it should be marked no discard. Look at that C line telling us how to make good C++, right? We should put in no discard, which means that we shouldn't, which means our compiler will give us a warning if we don't use the return value, right? And that makes sense because it's a constant method, meaning that it's not actually modifying any of its members, so it doesn't make sense to not use the return value. Because if you're not using the return value, then it's not doing anything. So then we mark it as no discard, which should just be a thing that it does anyway. Like, pretty much, if it's a const, it pretty much should be no discard. But it's a C++, you know how it works. Okay, so we have our buffer. So that's peek, but I do want the option to peek ahead multiple characters instead of just one. So the default is just to peek ahead one. So we'll have an int like count, like how many to peek ahead, or maybe we'll just do like ahead, and we'll make the default 1. So if you don't pass anything, it's only going to peek ahead 1, but you can peek ahead like 2 characters, right? And so instead of just 1, we can put ahead here, just like that. Okay, so that lets us peek, but now we need the option to consume. So consuming the character, I think, would make sense to also return that character if we want it. So we'll have a consume, and we'll just do one at a time. We won't have the option of consuming multiple characters for now, because then we would have to like return an array of them or something, and I don't want to deal with that. So consume, and this should be a char. And what we'll do is we will do m index, we will increment it by 1, and then we will go ahead and return, actually we can probably do this, right? This is pretty fancy, because we're going to return the current index here. So the current value of index is going to be passed in, and then it's going to increment it, all right? Kind of like that. I'm not a huge fan of doing stuff like this because this post-increment, pre-increment, or decrement kind of stuff is a little confusing, but, you know, it's C++, so we're not in something like Go where you can't do this or whatever. Even though I don't think it's a great idea anyway, but it's simple for this. Okay, so we're going to consume, and I think that's it. So now we can start to rewrite how we decide to iterate through this stuff. So I think instead of this loop where we get the index, we could just keep looping until when we peak there's no more value, and then we're going to consume our tokens inside of the loop. So that's kind of our way of incrementing the loop essentially. So we'll just rewrite this. So we'll do like well, actually it'll be a while. So while peeking ahead of 1 as the default doesn't equal actually peek dot, so while peek has a value, right? So if we peek ahead, it has a value, then we will keep going through. All right, this is already better than this for loop. Okay, just in terms of looks. So then we have this if is alpha. So we will put that in here, is alpha, and then instead of C, we can just do peek. So we will peek, and it's an optional. But we know that it has a value because we're checking that here. So we can go ahead and just take the value like that. And if we take the value when it doesn't have a value, it'll just throw an exception. But we're pretty confident that it has a value. So we will go ahead and do our buff.pushback and push back our character. And we're going to consume it here. So we're going to consume that character. And that's essentially going to be our like incrementer. I don't know why I put curlies there. And then we will do while is alphanumeric. So we're going to get the first letter and then continue consuming characters until we reach something that isn't alphanumeric, meaning that it's the end of our identifier / keyword. We haven't quite determined that yet at this point. And so we will go ahead and peek, and then we will go ahead and do buff.pushback consume. And this is a actually here we need to make sure that when we peek ahead, we're not at the end of the file, right? So while peek.hasValue and the value is alphanumeric, right? So we're already being safer here by doing this, because before we weren't checking if it was at the end of the file. So if we did something like just this, where it just ended here, it probably would have crashed, right? Because it would have tried to check for another alphanumeric character, and it would have just gone to the end of the file and then just died. So we're already being safer here, all right? And because we're just peeking ahead instead of like incrementing this index, we don't actually have to go back one because we're just peeking ahead. We're not actually consuming the token and then undoing the consume like regurgitating it or something. That's horrible. I should not call it that. Okay, now we need to check if it's a keyword, and everything's gone wrong because this is invalid syntax everywhere. So let's just comment this out so that this doesn't all break, and we still have a problem here. Some curly is not being matched up, it looks like. There we go. Okay, so then we check if it's a keyword, which right now we just have exit as a keyword. So this needs to be inside of, oh my goodness, what am I doing? Should be in here. And then if buff equals exit, then we push back our exit token, and then we clear the buffer. Right, and we don't have tokens in here. I need to create that again. Tokens. All right. And then we can continue. We can go ahead and continue. And then else will have some type of error. So else, and we'll actually be better about our errors in the future. For now, we will just straight up copy this dumb error message saying we messed up. Maybe in the future we'll give them a line number, maybe a little visual in the terminal pointing to exactly where they screwed up instead of just giving them you screwed up error message. Although I still think that this error message is already improvement over the standard C++ error messages. I mean, that's pretty much what you read in your mind when you see some templating errors somewhere. Okay, so enough being mean to C++, all right? We are using it, right? So we can't be that mean to it. Okay, if is digit, and then we can peek ahead, right? And we know that this has a value because we're checking it up here. We can go ahead and do buff.push back consume, and then while we still, and this is another thing where if we just had a number without that semicolon there, it would have crashed before because we didn't check if it was at the end of the file. We're just continuing to ask, is it a digit, right? So, or maybe it wouldn't have, because I don't know, doesn't end of file have a null terminator on the end of it? Maybe when we read the buffer in C++, I'm not sure. I could probably find that out very quickly, but I don't care enough. I shouldn't assume it. We should not assume it anyway. So we're going to go peek it while peek has value, and it's a digit. Peek.value. Value. Then we can go ahead and push back, consuming our character. And then we can add our tokens here. Add our token here and clear our buffer. Cool, that takes care of that. This is just boring refactoring stuff. I'm sorry. I know you guys want to get to parsing. I'll get to it. I will get to it. I promise. I promise I'll get to it. Else if we gotta clean up our code, right? We can't just leave it like it is. If peek dot value equals a semicolon, then we can push back. Ooh, wrong type of braces. Also, we should be continuing after all these. So I'm not sure if it exactly matters. I don't feel like thinking about it too hard, but I don't want. I don't know. I'm just not going to. We'll just continue after them. It makes me feel better. All right. Okay, so that takes care of that, and then we just have white space. Is space peek dot value, and this is just continue. Else you messed up again. Another very helpful. Whoa. Another very helpful error message here, just like that. All right, and then we can go ahead and return our tokens, just like that. Except it's not a function. I don't know why I call it that. And at the end, I guess if we want to reuse this, we would have to set the index back to 0, and the default should be 0. So we can go ahead and just make the index equals 0 in case we want to tokenize it again for some reason. We'll just put it there. Okay, so that actually, I think, cleans it all up. Must be marked explicit. Sure, we'll make it explicit, meaning that we won't implicitly convert a string into a tokenizer, I think is what that would have done before. Something like that. Yeah. Another great C++ feature, right? They just have to throw in features, but they can't make it the default, because that will mess up backwards compatibility, so you just have to do fun things like that. Okay, so now for our tokenization, we should be able to just, we get our token, so we need to create our tokenizer. Tokenizer. We'll pass in, because we're not doing anything else with our source code, we can actually move the contents into the tokenizer. Right? Look at that. We can move into that, move it in there. So what that's essentially doing is taking the pointer of the string and just passing in the pointer, and then just making this contents point to like probably just an empty string then. So that way we don't have a copy, right? So that'll improve performance, because obviously that's what we care about right now. And then we can tokenize, so we just do tokenizer dot tokenize, and we get our tokens out. And this should actually work. This should just straight up work. Okay, I'm tired of this doing this. I need to put. I want the terminal always open. There we go. So we have the build on the right, and we have our terminal on the left. So we don't have to keep switching back and forth. But that looks like it's still working. Oh yeah, look, it's still exited with 20, even though we don't have a semicolon. Oh, it never finished. When we compile this program, it just sits in an infinite loop. Huh. That is interesting. Why does it do that? Let's go ahead and debug it and then just like pause execution and see where it's at. Why exactly? So we're peaking. We're here. I mean, okay, maybe let's think about this. Maybe we are supposed to consume the white space. I think. We should consume the white space. And we should also consume this token. Okay, I see. We're assuming that in our previous for loop, we were iterating, you know, I++ up here in our for loop, but we actually need to consume these tokens explicitly here, even if we don't use their value. So that's something I didn't take into account. So now it finishes properly. And we don't get anything because our parser or our code generation expects a semicolon, or else it doesn't do anything. So if I go into here, put in our semicolon, compile it, and run it. Oh, you know what? That's not even the problem. I am all over today not doing things correctly. It's not a correct executable. Oh no. What happened? I feel like our tokenizer isn't working anymore for some reason. Let's see why. Let's look at what our tokens are. So we only have 2 tokens. We have exit and then the integer literal. Is this file saved? It's not getting the semicolon for some reason. This is what happens when you refactor code. You break it, and you don't know why. What happens if we put 2 semicolons? It works. So we must be consuming something extra when we shouldn't, but I'm not really sure where. Alright, so I just decided to just debug this line by line here. So we're at exit, and then we have our 20. So we have a 2 here, and now we have a 0. And where's our index? It's currently at 7. So 1, 2, 3, 4, 5, 6, 7. Or 1, actually, yeah, 0, 1, 2, 3, 4, 5, 6, 7. So we should be at the semicolon. So when we, where am I? So we should be at the semicolon, and then we continue, and it just exits. Maybe this is only supposed to be greater than length. Am I being dumb? I think I was just off. It's like an off by 1 error. That was the problem. That was the problem. Okay, so cool. This is working now. If we exit with 69, we compile. We get 69. All right, cool. All right, so it should have just been greater than, not greater than, or equal to. All right, simple little mistakes. All right, cool. So now that works. So we abstracted our tokenization. So now, let's get into, we won't refactor our code generation yet because we want to introduce parsing. So let's get into some actual explanation here, into something new. So what parsing does is typically you create something called a parse tree, or what's more commonly referred to as an abstract syntax tree. And so what that kind of looks like is, I'm not sure if I want to do this in Paint. It would probably be better to put this in draw.io, right? Ooh, I just got flashbanged. All right, so let's think of like a simple expression. So if we have exit, and we want to do some kind of math expression like 1 plus 2, all right? let's say we want to do an expression like this. So we want to exit with 1 plus 2, so exit with 3. How would we kind of turn this, what would our abstract syntax tree for this kind of look like? So we'd probably have, oops, I clicked the wrong thing. So our root node here would I guess be our exit. All right, our exit. And it contains some type of expression within the parentheses, right? So an expression could be some kind of mathematical expression, or maybe it could be a variable, but for now, we're just dealing with literals, and we don't even have any math yet. So let's just start with this simple example. So in here, we have some kind of expression, so maybe we can be explicit about that, and just put in like an expression here. We'll put it in brackets here. Since we're going to be explicit about this. And in our expression, we are going to have a addition, right? And then we're having an addition between the 1 and the 2, right? So we have a 1 and a 2 here, and we can draw lines that go like this. Beautiful. I think I've drawn something which is mildly penis-like. All right, completely unintentional. It just kind of happens. All right, sometimes they just pop out of nowhere. So this is our parse tree. So we have 1 plus 2, and so this is kind of the result. And then what we do is when we do our code generation, we give it this tree, and it's more easily able to traverse this tree of nodes, even though this is a very simple tree. When it's in the shape of a tree, it's easier to recursively traverse the tree and then generate the assembly that way, instead of just getting a list of tokens. It might not make sense why at the moment, but maybe you'll see later why that makes sense, especially when you have like nested expressions, things like maybe you'll have like or maybe operator precedence, right? You might have something like 1 plus 2 times 3 where the multiplication has to happen first and then the addition. In that case, you can't just go from left to right. Right, you're going to have some kind of, you need a bit more of like some kind of a hierarchical structure of what gets executed first. And then you take that, you take the result of 2 times 3 and you have to pass it into addition, right? So, but let's just do this right now. And so in order to do this, create this tree, we need to define these nodes, right? So these are like our abstract syntax tree nodes. So let's go ahead and do this. So right now we don't have parentheses in our exit, but in order to actually create this as well, typically what you have is something called a grammar. This is getting a bit into something called formal languages, which is very, academic. Like, a grammar is like essentially what a grammar is, and we're talking about a formal grammar here, not just your simple like English grammar. Like, what even is that? Like, English is all confusing. Are there even rules to English at this point? There's so many exceptions. But anyway, a formal grammar is more of a way of describing how a programming language should, like what a valid programming language looks like, syntactically speaking, right? And so there's a few different ways that you can write that out. There's different forms you can do this, but I'm just going to do this in a really crude way, non-standardized way. But I like to do this in VS Code because I want to use some LaTeX, because I think it could be it's a really good way of visualizing this. So I'll just create a docs folder and make our grammar. It'll just be in Markdown, and then we'll do LaTeX and Markdown. So we're going to preview our Markdown on the right here. Okay, so what we want to do is a grammar is structured in a way where you have these things called production rules, and then you have you have a list of productions that explain how you know what, let's just type it out because I'm having a hard time here. So for example, we might have our exit, right? So we have our exit node, and so we'll specify each node in brackets. Okay, and we want this to be in LaTeX, so I think I can just do $ like that, and now it'll be in LaTeX. And let's actually specify text here. So that's not in italics. Okay, so I can't zoom in on here. Really? I can't zoom in on this? Are you kidding me? It's so small. Markdown, really? Okay. I'll just have to make everything bigger. So we have our exit here, and what we're going to do is we're going to have, right now we just have one production where we have the word exit, and then in parentheses we have, and then we have a semicolon, and then in here we have another node, which is our, which will be another production, which is an expression, right? So we have an expression inside of exit here, and then we have another production for our expression, right? And we need to put in a new line here. Maybe we'll just do that. And so we'll have text, and we will have an expression here. So this is our expression, and we'll go ahead and align this to. If you don't know what LaTeX is, it's just a way to like format mathematical expressions, which looks a little ugly to write, I gotta be honest, but once you get used to it, you can create these like pretty beautiful, nicely formatted mathematical expressions on the right. Not that I'm really a mathematician. I'm not even close. Okay, so we have our exit here, and then our expression. This is a bit complicated, I guess, but because we can have a bunch of like nested things in here. You know what, for now, let's just say an expression is just straight up a number. Just to keep things simple for now. We won't deal with math. What we will do is we'll just have an integer literal. Alright, so maybe we'll just have like an I don't know, an integer literal. I can't put an underscore in here. Can I escape the underscore? I can. So maybe we have something like that, right? So we have our exit. And this is like our initial production. We'll just say the first one is our initial production. So that's where we start off with. And what we're looking for is the exit token. So maybe what we need to do, we're looking for the word exit, and then with parentheses in here, then we have our expression inside the parentheses, and our expression is right now just an integer literal. So this is like our grammar that describes our language, right? This is very basic, but you know, as we add to our language, I think this will expand, and you'll get a better idea as to how this works. And essentially, each of these productions will then turn into like the nodes that create our tree. So you can see like exit and expression here. Will be like nodes in our tree. So we'll have exit and then an expression, and right now our expression will just be a number, but in the future we could have like a number plus another number. I'll get into how it kind of works, because the thing about these productions is that there are some rules about how you can simplify these production rules in such a way where if you follow like a really strict standard, it makes parsing a lot easier, but actually creating the grammar itself a lot more difficult. So it's kind of like a trade-off. You can make the grammar really easy to like be human readable and easy to write and stuff, but then parsing it's going to be a pain in the ass or really slow. Or you can follow these really strict rules and write out your grammar in a very specific like strict format, but it will end up making parsing a lot easier in the future. So we want to create these two nodes for now. Oops. We want to create our exit and expression nodes, and then we want to be able to construct a very simple parse tree right now that will just end up, oops, I copied it twice. That will right now just kind of look like, this. So it's going to be a snake, a parse snake, an abstract syntax snake is what we're doing right now. So let's go ahead and create another header file. And this will be our parser. Okay, so let's go ahead and add it. We will do pragma once. I'll go ahead and include this so it stops annoying me. /parser.hpp, just like that. And then we will go ahead and create our class. This will be a parser, public, private, and we will have an inline constructor. You know what? I don't remember if I did everything inline in our tokenizer. Did I make everything inline? See, I forgot the inline here. All right. Okay. So we're gonna have an inline, and we'll make sure this is explicit, right? And we'll do parser, and this is going to take in a vector of tokens, right? Maybe we could do something like a span, like a read-only span or something, but I don't really care right now. So we're going to take this in, and these are going to be our tokens. And this is pretty much going to be the same way as we did our tokenizer, where we'll store it as a constant in here, because we're not going to need to modify this. We're only reading from it. And then we'll just move it in there. And I need to make this M for M tokens, and then we will move our tokens in here, just like that. Cool. So, and we're actually going to do the same thing here, where we're going to peek tokens and then consume them. So you're going to see that the parser like kind of works a lot like the tokenizer, but instead of like going through character by character, you go through token by token, peeking tokens and then consuming them. So like I said before in the last video, you can kind of combine the tokenizer and the parser, but the thing is, I find it a lot easier to just have the first pass, like the tokenization step, to just break it into these bigger chunks, which are the tokens, and then do another pass where you're just going through the tokens, instead of having to deal with individual characters in your parser. It just makes, like, if you combine both of these into one, things just get, I find, a lot messier. So actually, we'll just be able to straight up copy and paste this code in here. So we'll just peek and consume, and then we need an index. So we'll have int index equals 0. You know what? This should be not an integer, but a size type, right? Because it's kind of like an index into something, whether it be an array or a string. So I think we'll make it a size type instead. And then we're not dealing with source here. We should be dealing with our tokens, right? And so this is pretty much the same thing. And this will return an optional token, just like that. And then this will consume our token and then return a token. Okay. And it's not length, it's size for a vector. All right, and then we will just return our parse tree, which we don't have a type for. So let's go ahead and create our nodes. So in here, I think I might want to put them in a namespace just so they're kind of grouped together. If I can spell it, and we'll just do like, maybe we'll call it like node. Yeah, we'll do node, and then we can do like, we can have our exit node, and then we'll have like our expression node. And in here, our exit, if we look at our production rules here, it has an expression in it, right? So whenever we have an exit, you're going to have some kind of expression. Now, I think in C, you could just do exit without, like, you could just do exit like that, but we'll just enforce that it has to be explicit. You have to pass something into it. So we're going to have an expression. So let's go ahead and, I don't think I'm going to use pointers at all for this, or references. I think we'll just keep copying things around for now. But in the future, we might want to use something like an arena allocator, or some kind of allocator where we can, that might not even be necessary. You know what? I'm getting way ahead of myself. Premature optimization is the root of all evil. Let's just copy everything, okay? So we have our exit, and we're going to have our expression, which means we actually need to put the expression first. So in our exit here, we will have a these need to be capital. I'm getting confused. This exit expression, which means we'll have an exit here. And then, you know what? I'm not liking this. I think what I want is I'm just going to prefix everything with node. Like that. I think I'm going to do that. And then we'll just do like exit. We won't do M because it's struct. Okay, so we have, I put it in the wrong thing. This should be a node expression. Node expression, and then expression. Okay, and then our expression will just contain our, an expression is just the token, the integer literal. So it's just going to be a token of like int literal. Int literal, like that. This is included in here because it's included in here. Oops. I don't like that because now that this is order dependent. So if I like swap these around, if I can figure out what is the key to like, I don't know what the key is to move them. Yeah, so I'm gonna be explicit about this and hash include tokenization in here. Okay, so we have our nodes, and so our root node is just going to be exit for now. It seems a bit strange, but so our exit is going to our output here is going to be node exit under parse. All right, and then. Yeah, so that all works. So inside of our main, we don't have a parser yet. Okay, so we need to actually do our parsing. So this is going to pretty much work the same way as our tokenizer, where we will keep peaking tokens until there aren't any left. So while peak has value, so we'll keep peaking tokens, and then at the end we'll set the index to 0, and then we will return node exit. So we'll create a node exit here. You know what? Let's actually return an optional. In case it fails to parse, then it won't return anything. We could throw an exception, but I really do like having like errors as return values. But instead of having like a result type, we could. I just use optionals. So I just do like if there was an error, I guess you just return null. So let's go ahead and create that right now. Node exit, exit node, and then we'll turn exit node. So this will default to null. And so we'll keep peaking tokens, and we'll say if peak dot has value, well, it's going to have a value because we start off checking. So what if peak dot value, as this is a token, we want its type. So if its type equals token type exit, so if it starts off with exit, okay, we start off with the exit, and then we actually have to parse for an expression, right? So I'll show you what I mean by this. So what we actually need to do is have this optional for node expression, and we need to parse for an expression. Okay. And then in here, what we'll do is we will get our expression. So if parse expression, we'll actually create this. We will assign this variable in this if statement, and I'll show you why. So parse expression, else, invalid expression, and then we will we'll just exit with exit failure. Okay, maybe I should explain what I'm doing here. So essentially what I want to do is that each production will be its own function / method, right? And each production is its own function that returns an optional to the node that's on the left, right? The node that is on the left of each production. And the reason why I want to use an optional is because if we are unsuccessful in our parsing, like we don't get, like, let's say we try and parse for an expression, but we throw in another, like something that's not an integer literal, then we want to return null, and then that will like crash our parsing. What we probably should do is use like a result type, but I don't really feel like creating my own result type, and optional is already a thing that exists, so we're just going to use that. So we're pretty much treating optional as like a result, but without having to be specific about what error we are returning. So what we can do with this syntax is we're assigning our node expression inside of this if, and then it's implicitly converting this node expression to a Boolean, which what that will do for an optional is it will return true if it has a value and false if it doesn't. So if this node expression does not have a value, it will go to this else. Otherwise, if it has a value, we will actually be in this if statement, right? So a bit strange to kind of see this. We could put this outside of the if, but then we, be a little bit more explicit, but this is more compact. So inside of our parse expression right now, our only valid expression is just an integer. So what we need to do is if peak dot has value and peak dot value equals, or dot type equals token type integer literal, then we will return a new node expression which has, let's see, so we can do node expression. Can I just do, it's an optional. Okay, so what's the right way to do this? Integer, there we go. Okay, so we could do this, and then we give it we will consume this token. All right, we will consume the integer literal, just like that. Otherwise, else return null, like that. Except we are missing a semicolon. Okay, all right, cool. And actually in here we need to consume the exit, even though we aren't doing anything with it. We need to consume this exit here. So then we parse our expression, and then if we get the expression, that means that we can, that means our exit node, we can actually create our exit node. So we can give it the expression and we can assign it to node expression like that. And this we verified this has a value up here. So we don't have like type narrowing like TypeScript. So we actually have to be explicit with the compiler. It can't be like, oh, you just checked if it has a value here and then immediately forgets the next line, because you might have multi-threading and all that, blah, blah, blah. So you actually have to be specific about that. And then right now, I guess this would be fine, but we should check for our semicolon, even though we do have enough information to just return our exit node here. We should check if we need to do if peak dot has value and peak dot value dot type equals token type semicolon, then we will go ahead and well, we don't need to do anything with it, so we can actually just invert this to be negative. So we'll do like a not and a not if it doesn't have a value, or it's not a semicolon, then we have to give it an error, right? Kind of like that. Then we return our exit node. Okay, so that was, I think, a little confusing. But I think you'll see that when we add more productions and I add more of these functions or more of these methods for parsing individual nodes, and we have and we just do more of them, I think you'll start to see the pattern, and you'll see why people use things like Antler or something to create parsers instead of just hand coding your own parser, because you'll see that writing out the production rules, you'll see that they really do map pretty much they map very specifically to the functions and the methods you write. So it makes sense that you can create a program that will turn these production rules just into code for you. But we're just doing it all ourselves, right? Because it's for learning, education. It's good for the brain. Okay, so this should do it. But what we'll get back is now a node exit. And now we have to do our final step, which is code generation. So these are our three major parts: tokenization, parsing, code generation. And code generation will take in the root node, which is our node exit, and traverse that tree. And then while it's traversing, it will go ahead and create the assembly code. All right, so let's create another header for generation, generation.hvp. We will do pragma once. We will go ahead and include generation, just like that. And we will go ahead and create our class generator, public, private, and then what we will do, so our generator, we'll go ahead and take in our root node. So node exit root. This is the root of our tree. So this root node will change when we add like functions, and then have like a main function will probably be, and then like having some kind of a better root other than just this one statement, right? This is just temporary for now. So we have our generator, and what do we want to do in here? We'll have as a const node exit root, and then mroot. We'll move our root in here. Gotta put in our curlies, and I think we'll just return a string. So we'll have generate, just like that. And I think at the moment our generator won't actually modify anything, so this can be const for now. It probably won't stay const in the future, and because of that we can make this no discard. But we'll just make our linter happy in CLion. So we take in our node exit, and now we need to traverse this. So what we want to do, we're gonna have like a sort of similar thing where we have a different method for generating each individual, where we have we have different methods for generating each node. But for now, since we just have this such a simple parse tree, I think we're just going to, if we see an exit, we'll just generate the entire program right now. So we will go ahead and say if, actually, because we just start with a node exit, we can just generate this whole thing right now. So let's take some of our code that we used before and paste that in here. So we have our output. We have our global start, and then we can go ahead and take all this, and then we need to take in, so now we can do our mroot dot expression. So we're using the expression from the exit from the exit node, and then we grab the integer literal, and then we grab its value, which is an optional, but we're just going to assume it has a value for now. And there we go. I think that's it. And then we can just return the actual string, because this is a string. And there we go. So that actually really simplifies the code for our code generation to just that. Cool. Cool. So inside of our main, we can get rid of this tokens.2 ASM, which is ugly, and things should actually simplify themselves quite a bit. So we need to create a generator. So we'll have a generator, and we will pass it in. We don't even have a parser yet. So we'll create our parser, and we pass in our tokens, and we'll move our tokens in here since we're not doing anything with them anymore, just like that. And then in our generator, we will go ahead and we need to actually parse things. So we have node exit, but as an optional node exit, and then parser. We'll do root. We'll call this our tree. And we'll do parser dot parse, and then if it doesn't have a value, that means we were unable to parse a valid exit statement. We will just give an error. See error. No exit statement found. And then we will go ahead and exit with exit failure. So then in our generator, we can go ahead and pass it our tree like that. And then in here, inside of our file, we can just do generator.generate, pass that into our output file, and then assemble it and link it, and that should be it. So now if we go ahead and run everything, we get a nice infinite loop. All right, what I'm having a feeling is what I did is during our parser, we need to consume our semicolon. So actually, we do need to do something if we get our semicolon. So let's actually invert this correctly again. Put the error message, and then we need to consume our semicolon. You're probably wondering how I was able to identify that quickly. I don't know. Magic. And it works. Okay, well, it didn't get an infinite loop. So let's go ahead and run this, and we get 69. And now if we do 100, we get 100. Okay, so we didn't make a whole bunch of progress in terms of improving our language, but the code now makes a lot more sense. We're doing proper parsing, we're doing tokenization in a much better way, and then now we're actually doing some kind of code generation, although this code generation still, it's not our language isn't complicated enough to really see a pattern start to emerge in our code generation yet. And what is the problem here? Okay, this wants to be explicit too. Okay, C-line, okay. Do we have any other warnings or errors here? What do we have? What is the problem? Unused include. Really? Oh, because what? Generation includes both of them? I hate that. That's horrible. Oh yeah, because it includes parser, and then parser includes tokenizer. Oh, this is horrible. I hate the way this works in C++. I want normal imports. I know it's kind of coming with modules, but you know, we'll just deal with it. So no other warnings here. It looks check for any warnings. There's 3 warnings here. What's the matter? Is it unused things? Tokenizer is never used. But I think it is. It is used. Interesting. Again, C-line being very helpful. Okay, so this is, I think we're going to stop there today. Next time I think we'll get into like proper expressions where we'll start to do math, right? I think that's the next move, so that we can do something like exit 1 plus 2, and then maybe even get into like operator precedence where we can do like a 2 times 3, and then add the 1. right? Because now we have to do something fancy for these kinds of expressions, but then we'll start to expand our parse tree, and which will make our code generation more complicated. But then you'll really start to see the patterns emerge in all these things. So yeah, I think that's it. I received a lot of good comments on the last video. I wasn't expecting so many people to actually watch that, but I'm glad people are enjoying it. I got a nice, quite a few pointers about some better ways of doing things, and some like someone telling me, a lot of people telling me what iOS stands for, which isn't an Apple product, but it's instead input-output stream, right? For specifying the flags, the access flags for files. So nice. Thanks for all the people that mentioned that. So I think that's pretty much it for this time. I think I will go ahead and see you guys in the next one. Hope you enjoyed. Bye.